Okay, today's lesson for AP Calculus deals with second derivatives. So we could do implicit and explicit. The explicit ones are the normal derivatives that we did. It would be an example something like this. Y equals 3x cubed minus 2x squared minus 4x plus 3. And so you take the first derivative, which is y prime. I bring the power down just like normal derivatives. And we did these things last year. And then you do the derivative of this to get the second derivative. So we'd have 18x minus 4, and the constants go away. So that's pretty straightforward. So now I want to look at what happens if it's implicit. So an implicit example could be something like x squared plus y squared equals 25. So here's an equation where now we're going to take the first derivative. And to do the first derivative, we got to do our derivatives of the different parts. So when we do the x, we just get 2x. But when we do the y, we end up with 2y dy dx. And then a constant derivative is 0. So now what we do is we solve for dy dx just like we have in the past. So I minus the 2x. I end up with 2y dy dx equals negative 2x. I divide by 2y. Now I would recommend, if you can simplify, when you're doing these, you want to try to simplify. So dy dx equals negative x over y. So now at this point we want to take the second derivative. So d squared y dx squared. When we do this, we're going to do the quotient rule. So the quotient rule says I take the derivative of the top, which is negative 1, times the bottom unchanged, minus the top unchanged, and because it's negative, it's going to become plus x, times the derivative of the bottom. Well, derivative of y is 1 dy dx all over the bottom term squared. Now, the difference with this and what we did before is we're going to take the dy dx, and what we're going to do is we're going to replace it with what it was from the first derivative. So this is our first derivative answer. To do the second derivative, I don't want to have dy dx in the answer, so we're going to put that in here, and we're going to end up that this becomes negative y plus x times, and then I have negative x over y, and this is all over y squared. And that way we get it in terms of one variable. Now, because I want to try to get things so that I can clean this up, I can combine. I'd have negative y plus or minus, because of the negative sign here, minus x squared over y, all over y. And if I wanted to write it so I didn't have a fraction over a fraction, what we'd do is we'd multiply this first term by y over y, and then I can actually rewrite the top. So there's one single fraction. It would be negative y squared minus x squared over y, and this is still over y squared. And because of that, now what I can do is I can put this y into the bottom. And so we end up with negative y squared minus x squared all over y cubed. Now, if you get stuck and you don't want to go any further than this, I'm okay today that you leave it like this, but this would be the simplified form if I got rid of the fraction over a fraction. And hopefully that'll help so that you can do the implicit differentiation for a second derivative.